Ctrl-Flow. Man, one of those days that you don't want to do anything, but you gotta do something. So I guess today it's like Ctrl-Flow or like dispatch table or like whatever you want to call it, branching. This is a first gen i7 with 32 gigs of RAM. I think technically it can handle 64, but I would have to find a better motherboard. So like Raspberry Pi 4, I still have to like get that set up. In the stats online, just nothing is ever right. The bandwidth, the specs, the cores, the memory, the instruction set, nothing is ever, never ever correct. This website says I swear to cheese. Max memory is 16 gigs. But clearly, physically, on this motherboard, I have 32 gigs of RAM. So the max memory is not 16 gigs. So like, technical, theoretical, nobody has time for that. So I gotta waste my time benchmarking and testing, and I hate wasting my time doing this because I gotta like set stuff up literally only for like benchmarking testing, because you can't just like run actual code until you get it set up. You don't want to waste time setting stuff up, because you're wasting time. There's like no in between. So like typically there's like x86, 64. And there's like ARM. ARM 64, whatever. So like ARM 64, the ARM CPUs, they're like far from impressive. ARM 64, whatever. They're very disappointing processors. And like a pain in the ass to work with. What's it gonna do? Dang it. Oh yeah. So like ARM64, or like the ARM CPU in general. The CPU, whatever, it has instructions and then data. And then there's immediate values. Those are stored with the instruction, separate from data. So it's like in the instruction. So like if you have like add, let's say like that's a machine word like. (0xFA), whatever. Alright, so like let's say like this is like add, right? So when the machine runs, it sees this byte and it goes add. And let's say like this decodes this saying like let's say like this decodes to like register 3 and you're adding an immediate. So like that means like register 3 is like basically probably in a register file. So that like just exists. So when the CPU runs, it's gonna check the instruction. And then it's gonna like register 3 and there's immediate. So like the immediate has a size. Let's say it's like a 64-bit number. Alright, that means the 64-bit number is going to be in memory right after the instruction. Alright, so like, how do you pass in a 64-bit number to an ARM64 when it's a 64-bit immediate? Oh, you can't. Let me double check that. Because there are exceptions where you can pass in a smaller number. And then it'll set the sign bit for the rest of them. Set them all on or whatever. And we can pass in a smaller number and have it expand, and it treats it as a bigger number. but you can't physically pass in a literal 64-bit number. So technically speaking, it's all about the technicalities. And that's why I gotta waste my time testing stuff right now. Because ARM CPUs are a disappointment. Here's a benchmark on branching. x86 versus ARM. I gotta find it. Oh man. Oh, there it is. No, it's not. Oh wait, is it? Oh my god, it just needs a freaking website. Here it is. Oh. Alright. Branch predictor. So x86, 64. You can clearly measure how long things take, okay? This is what, AMD, whatever. Basically any x86. So that's like this family of CPUs. These CPUs are high performance. Deterministic, solid, stable CPUs. ARM, any ARM CPU is basically like, it works, but it's kind of like a joke. So here's like x86. So like branching. Conditional jumps not taken, they incur no penalty for branching. 0. Basically 0. And then any kind of branch is going to take time. So jump equal taken or jump takes time. So jump equal taken takes more time than just a normal jump. But any kind of jump takes time. That's the purple one. Green is like jump equal taken. So the condition adds to the overhead compared to like when it's like a jump that's like to a known location. So I'm not sure if he has extra indirection for the purple line, the jumps, or if they're like direct jumps. So I'm gonna, I guess, test that because I gotta waste my time on this now. So this is x86, so like ARM 64. So jumps, they have a call and then a return on top of it. Man. Everything fucking sucks dick. I can't waste forever testing stuff. So like x86, I'm pretty sure it has a jump with like immediate values. And the only reason it supports that is because you can't have a full 64-bit value. In the first place, right? Man, this sucks. I just don't give any fucks, but now I gotta like figure it out. Hooray. And then apparently there's like a 32-bit mode call compared to like the 64-bit call or something. So I gotta like test all these things. Because basically, Alright, so like Apple Silicon M1. CPU cycles, predicted call return. Apple Silicon. So like comparing numbers in this chart with x86 is unfair since ARM call operation differs substantially from x86 variant. Like in the chart before, we can see a big benefit if hot code fits within 496 bytes. Otherwise, you can count on 46 byte or 46 cycles per call return sequence, or branch link return as known, whatever ARM. Alignment issues, unclear what they are caused by, blah blah blah. So predicted branches, usually 3 clock cycles, even unpredicted branches never cost more than 8. So like ARM CPUs, they seem to be like a CPU running inside of the CPU, because it's not the actual CPU. That's running. There's like a thing inside of it, which is like the whole point of ARM. How many cycles? So in x86 it says conditional jumps. There's more articles, but this is like the only one that actually like makes sense or like seems legitimate. It says like blah blah blah. Blue line hovering at 0. This is a jump never equal taken. 0.3 clocks a block. No matter how many blocks we run in sequence, the takeaway is clear. You can have as many never taken branches as you want without incurring any cost. So that's like this blue line at the bottom is jump not taken on x86. There's no cost when it's not taken. But if it is taken, it's like the green line here. Otherwise it's the purple line. This is like 0.3 cycles. Or clocks. Clocks, cycles, man. Some made up words. So it says, when it fits in 496 bytes, you can expect predicted jump to cost 1 cycle. You can expect a cost of 3 cycles per predicted jump. It says if we don't trust the flush BPU code adopted from Matt Godbolt. I'll just text to speech chat in a second. This reveals 2 things. First, unpredicted branch cost seems to be correlated with the branch distance. The longer the branch, the costlier it is. We haven't seen such behavior in x86. So like ARM, it may not have when the CPU runs whatever, it seems like it grabs big chunks of memory. So maybe this is like 1024 bytes. And then it keeps these in memory. And it has a smaller tag cache. And it stores the entry of these things. And maps it out, whatever. So when it loops, it can loop through here first. And then it gets the actual memory here. And this stuff, the memory transfers, they seem to be like hardwired or something in the CPU, whatever. So it does like a big chunk of operations to and from the RAM in big blocks, whatever. So whatever like latency there is on x86, since it's set up this way, whatever, or it could be like here or here, or if it's not in here, it has to get it, it loads it up and puts it here maybe. Since it works with bigger chunks, you'd have to jump like pretty far to be out of the range that it's not memory. But on ARM, I don't know how to explain it. It seems like it has to run through the memory until it gets somewhere, and then run it, and then run through the memory again, and then run it. Like they're missing, architecturally, something that would make it more stable or faster, like, I don't know, that's why ARM's cheap. Because they're like crappy designs. Some shitty processors. So like unpredicted branch cost seems to be correlated with the branch distance. So why exactly? It is like really complicated. So I don't know, whatever. All I know is it's garbage. And then it says there's a cost to self. We saw predicted sequence of branches cost and what's supposedly unpredicted jump cost. And the first chart, blah blah blah. Branch predictor seems to become ineffective. The supposedly flush branch prediction seems to show the same cost. For example, the cost of 64-byte block jump with a small working set, 3 cycles. Misses 8 cycles for large working set, both times for 8 cycles. Seems that branch prediction buffer is linked to L1 cache state. A possibility of such a design back in 2016. And then there's something about cache misses, and it's along the line. It takes like I don't know, whatever. So in ARM64 are 64-bit immediate values possible. Such as move R0, and 64-bit without using an address to hold the 64-bit value so it can be loaded. It says no, not in a single instruction on ARM64. So like assembly wise, this really pisses me off. I'm gonna waste my time figuring out this trash. Because these companies are cheap as hell. And you pay so much money for their freaking hardware. And they're making garbage. And then x86-64. Since the 64 part, AMD adopted the same laziness from ARM CPUs. So like a 32-bit on x86 is fake. It's a 16-bit CPU, faking 32-bit. So AMD extended it, the 32-bit encoding, to 64-bit. So they use the same technique to fake it for 64-bit. When Intel wasted time making a CPU that they can't even develop because they don't know what they're doing either. There's literally one guy that developed the first one, and ever since him, there's a bunch of idiots in charge. They don't know what the fuck they're doing. So all they do is copy. Maybe chap, I don't know. Alright, so like it says a no, not in a single instruction. Alright, so like AMD, they basically like adopted the laziness from ARM64. So like most programs are written in C. And C language is also a form of laziness. So like inflation goes up. And you pay more money for the same shit. So when you pay more money, you expect to at least get the same. At least the same kind of value that you had at one point. Because like let's say like this is Pepsi or soda. So like when you pay like $1 for soda, or pop or whatever. You get hit with like inflation. And we all know this, whatever. So like now, what the pop that used to cost $1 now costs like $6. So what you would think, or I would assume, is that what you end up buying is still soda. You wouldn't expect to be less. You'd expect to like pay $6 and it costs more, but you still get that original soda or pop. But you don't. You like half of it. You end up with like less than we would have had before. And it's really frustrating. It's like, it's pathetic. The laziness is like when you work for money, you get paid, right? And you get paid for your time. And that's what you get paid. So if you're getting paid for your time and you're paying for a CPU, not pop, we're talking about computers like a CPU. It's not cheap. Alright, so like, what about x86 64? Is this possible? Is it possible on x86 64 to load 64-bit immediate value? Nope. I gotta waste my time testing this. So on x86 64, our 64-bit immediate value is possible, such as move R8 or R15, doesn't matter, 13, 0x86 whatever, 64-bit number, without using an address to hold the 64 value, so it can then be loaded. Man, it really pisses me off. Okay, what's it talking about? Oh, it can't. Okay. So why is it lying to me? You know what? AI is a joke. It's a fucking lie. Bunch of idiots. After Microsoft. Just I swear to cheese. Alright, so like, alright, so on x86 64. What's the instruction to move that to RBX? Alright, so it says do this. Alright, let's see. I'm gonna move RBX this. If this is possible, that'd be great. Except it seems like it's not. Because I tried to move 64-bit immediates last time. And it just would not work. Man, 64-bit assembly is a joke. It's not even a 64-bit CPU. So I'll try this in a second. Alright, so how much is the newest i9? How much money to make an i9 gaming rig? Can you have 256 gigs of RAM? Only 599? $10,000? More like 14. Alright, so when you buy a computer, it's not a can of pop. I mean, you're spending your own money. Some people don't have to work as hard for their money because their time's worth more, depending on what they can do, because they get paid more for their time. But even they get ripped off. So everybody gets ripped off, basically. It's like maybe like 4,000 for a PC. Back then, whatever, maybe like 5, 10 years ago, 15 years ago. Well, maybe not that far back. So I don't know, whatever. So like inflation plus whatever. It's what? 5,000 maybe. So like, you know, with like $11,000 computer. And you're getting like the watered down computer. Because it can't even do what it says it does. But a 16-bit CPU that actually did 16-bit operations, whatever. I don't think it was actually 16-bit though. It's like 32-bit. That's like super fake mode. At the instruction level, all 32-bit instructions, they start with the same exact byte. It's like everything fucking sucks. I'm done complaining in a second. I'm gonna waste my time benchmarking and testing. Everything sucks. Chatbot, I will destroy you. I'm gonna put you out of business. Yes, okay, so. This is really annoying. Just will not. God. Is it really 66? Oh, so funny. So 66. Alright, so 0x 66 enables 32-bit operation. Alright, so chatbot here, it said add AXAX is 0C1. And it says add EX 32-bit is 6601C0. Alright, so you see how it's the same instruction? It's a 0, 1, C0, and then 0, 1, C0. So the only difference is this byte. So the instruction set is the extended 16-bit, so that's why it's extension. So 64-bit, they extended the extension, but they tweaked it. And it's lazy, and we pay so much money for a fucking computer to get lazy. It's great stuff, man. Super cool. So all this stuff affects performance. So call 32, return, jump, memory, jump, register, jump, immediate. There's also like jump, register, without memory direction. I don't even want to do this. So everything got way more complicated than I thought it'd be. It's like this here. This relationship. Alright, so like this relationship with the nodes, whatever, where it's like a node H is passed in as a child node to J, and then it goes out back to H, and then down into L. Let's pass that back in A. It's like a relationship like this with nodes it's a lot to chew. A whole lot to chew. And then when you tie it in with the Vulkan API, the GPU, or just any hardware in general, it's even tougher to chew. So this is some really like freaking overdone steak, or really fucking like just yeah. So I gotta chew this or finish chewing this. So what this breaks down to though is CPUs are fake as fuck. There's something real that's the core of the CPU, but everything on top of it's fake. It's not fake, it's simulated, or whatever you want to call it. There's a bunch of like instructions that run on the CPU. This program is garbage. It's straight up trash. Everything is garbage. It didn't even save. I hit the save button here, and it didn't save. Alright, so CPU. It didn't save. And it changed colors, cool. It stopped working again. It's not working. Just restart the program. And I hit save. I fucking clicked save. Here I go, I'm clicking save. Save, save, save. Oh, it's save, save, save. It says save successful. So I'll just restart the program and then get back to what I was doing. Yes, it did save. Cool, awesome. So these instructions, they run on the CPU. There's different CPUs. Even if I pick only to support 64-bit, they're all different. I have like a complex node system. Because inflation goes up and things get cheaper and faker. So if I make something that's legitimate and does groundbreaking things, then it's a lot of money for me. And then I get to give back by making something that's not affected by inflation. It's only affected by the time it took me to make it. So like, if I make something better and I get paid a shitload of money, do I deserve that money? I don't know, I think I do. And then if I make money, there's other companies that won't be making money. But companies that are playing in this game, I swear to cheese, this game of like taking people's money and pocketing it and not giving them what they pay for, because I buy things too, and not getting what you pay for is really insulting. So those companies, I guess I'll be making their money. They're not doing anything with it anyways. So that's why I'm setting stuff up on this really old CPU. Because whatever runs on this one will run on all the new ones. And I gotta like add support for all the extensions to the CPU. So these instructions, they run on the CPU. I have this complex node system. And I have like a dispatch table, I guess you could call it. But it's not that simple. So like a normal dispatch table, whatever, like with the Unity game engine, Unity, I will never waste my time with your products again. In Microsoft, I'm gonna put you out of business. I mean, you guys, you're gonna fucking sink. You're gonna go down. Bad, bad, thieving, stealing, corrupt. You guys will go out just like your phone, your Windows phone. Be fucking obsolete. It's like this game engine runs off like C Sharp, whatever. The garbage made by like Microsoft. And that's why the games, they look like subpar. Because C Sharp is the definition of subpar. So like these game engines, oh, I'm making a JavaScript engine, but I'm going to call it a JavaScript assembler. Because people use the word engine the wrong way. They think making something in the thing is an engine of that thing. No, it's not. The engine is the code that's compiled to run the thing. If you're making something with the thing, you're using that development like tool with the tool. You're not making the tool. You're making it with the tool. So like Unity game engine or like Unreal game engine. So I've messed around with Unreal, but I didn't really actually try and make anything yet. But it is slightly better than Unity. But it, like, I don't know, whatever. So like I need to make something that none of these do. That neither of these do. There's other game engines too, whatever. There's also like, what's Steam use, whatever. So I don't know, whatever. So normally you have like a dispatch table, and it's like entity, component, whatever. So like you have like entity, whatever, and then it holds components. And like there, this is so complicated. But in a nutshell, let's say like the component has data and it calls the dispatch table to run a routine. And let's say like it's pink because it's tied directly to the table. Alright, so like the basic, most simple game engine. So like game engine is misleading as hell. Cause like, oh, what's the bubble thing? Hey, I was later just got off work. Yes, my chair. What is this bubble thing? What do you mean bubble thing? OSRS. No, I don't really play that. I don't think I've ever played OSRS on my account. What the hell was I doing? Alright, so like Unreal Engine. So like there's a game, whatever. And there's like it doesn't even matter. Let's say there's like the bird and the person, whatever. It's two entities, whatever, two cars, doesn't matter. It's like entity car. And which bubble thing? I'm not sure. Alright, so like the modern game engine, like Unity, Unreal, whatever. they I don't know. I have like really high standards. And technically speaking, just I would expect certain things that don't exist. So I gotta figure out how to make it exist. This fucking sucks. I hate 64-bit assembly. Not even 64-bit. Everything's in C language. Things freaking lazy. So like, I'm using a first gen i7 to get it to run on these computers, first gen i7, also on the new i9s. So I'm gonna like optimize it too for the extended instruction set. Really the CPU is not what it used to be. I'm just gonna go around from topic to topic. I don't care. x86 whatever. Kinda runs like this. Has like big chunks of memory. Loads them up. Has like a tag cache. This program sucks. And x86 has the original register set, whatever you want to call it. But it also has extensions, like the SIMD. And that's the real CPU. It's like x86 has the original stuff, like the original registers. It's like x86 64. They have like the original registers, and they extended it for 32-bit. And they extended it again for 64-bit. And then they have SIMD whatever. So like the CPU runs behind the scenes off like chunks of memory in the CPU. cache, whatever, to access the chunks of memory. And then it runs the old registers, except it's optimized for the SIMD, whatever. And that's like a different instruction set. But then it still uses these original ones for Ctrl-Flow. So like SIMD, whatever. So like kind of like here, not here. Alright, so like MMX, SSE, AVX, EV, 512, AMX, whatever. These are like what the CPU really is now. And the CPU is designed around this. And then like the original instructions, or not instructions, registers. They're not even registers anymore. They're in like a page table, whatever. And it like simulates those. And it's just, everything is so complicated and fake on top of it. So like supporting first Gen i7 means mostly that the original instructions, not instructions, registers, it'll run better with these for the older computers because that's what they have. And then it also has some SAMD. I think it's SSE. But the newer CPUs, I might have to like write code specifically for those instructions, like AVX 512. So I'm pretty sure this CPU first gen has this for sure. No, at least this. MMX, whatever. Huh. There's no way. Oh my god, I just realized everything's fake as hell. Really? They just map these to generic registers. Wow, you guys are lazy pieces of garbage at Intel. You guys are absolute garbage. Everything is so dumb. Oh my god. That's why registers are as slow as memory. Duh! How am I just realizing this? Because none of it uses registers. It's all duh. Duh. I'm just realizing this. How did I just... Okay, so... The MMX instruction set has a, what is this? An add... Pack 16-bit integer AB, store result, destination, whatever. That is hilarious. Man, what a trick. The even funnier thing, whatever. The new Intel CPUs, they're only 4-core, not 8-core. So I don't know if they're like selling 4-core CPUs again to save money, But Intel, man, you guys are lame. What is the newest? What's the name of the series? Arrow Lake. Alright. Raptor Lake. Alright, so like here where it says memory 64, the funny thing is x86, they're like, there's no memory to memory operations. And then boom, everything's in memory. And it's all memory to memory. No wonder it's so slow. God damn. Alright, so right here it says memory to memory, right? So that means on the CPU, the modern CPU, the modern piece of trash, I still gotta test if you can move the 64-bit. I don't think you can. Cause like, yeah, alright, anyways. So like this is like memory to memory. So when you do move RBX, oh my god, that's why it's a register file. Oh wow, how am I just connecting the dots? Man. Alright, so move RBX. It's called a register file. Because RBX maps to a fucking file. Register renaming is switching around the fucking pointer to which one it is. Holy fuck, this is fake as hell. Man. That's not optimization. That's selling a shitty CPU that's memory bound. And then calling it a register. Holy fuck. You guys are shit. Wow. Alright, let's say like we have a register file of registers, okay? And then I have a tag file. Now this tag file is going to store which index REX is at. So let's say we start off here. So we got 0. This one's to 1. This one's to 2. This one's to 3. Oh, and then the ports on the CPU. Oh my god, it all makes sense. So the reason why with x86 they didn't do memory to memory was because it's really fucking slow. And that is literally what every modern CPU does. Memory to memory. Alright, so like a tag file. So let's say REX is here. So you encode the instruction. Let's say it's like you're encoding the instruction 01C0. Now this breaks down to machine code. And it's encoded because it's an instruction. It tells the CPU what to do. Alright, so like, I think the second byte says which registers. So I think it's the bottom 3 bits to pick registers. So like register A maybe 0, register 1 or B is like 1, register CX is maybe 3. So for register 3, maybe like these 3 bits, then these 3 bits, and then you ignore the top 2. So like you change these bits to pick which register, whatever. Chatbot says exactly where x86 encoding actually clicks. What the fuck does that even mean? Let's decode it. No, go fuck yourself. Since that alone's not enough to pick registers. Well, no, duh. Second byte is the mod RM, so it is 3 bits. Alright, so C0. Oh, it's the second byte is C0, okay. Man, I hate computers. I actually got something out of like explaining this. I gotta stop stalling to get something done. So it's 2 bytes. So 1 1. So these two. I don't remember. Alright, so like this instruction. This specifies which registers. So you pick which one you want. So like AX is 000. And then BX is like so these 3 bits, pick which register, depending on the bit set. And these 3 pick this register. And I don't want to guess if I'm wrong. So these 2 bits. Man, there's. I'm gonna mix it up with ARM or something. Alright, I need to get something done now. Alright, funny. It says register direct mode. No memory access. No memory access. Funny. Alright, so memory. Register direct mode. No memory access. That's what these 2 bits mean. That is hilarious. That is so funny. The funniest shit. Alright, that's what those two bits mean. The rest of the, you can ask Chatbot. Chatbot's gonna lie to you, but you could ask Chatbot if you want to figure out. So you can ask Chatbot, then you can like look it up. And you don't know to test it or run it. So since the CPU is set up like this, it's designed literally in every single way for SAMD. I mean, even the old instruction set is just a layer on top of it to map it to SAMD. Because it says no memory access. Oh, that is so funny. Alright, so Intel, with their memory 64 add, whatever this add right here, where it's just a normal add. What if they don't have normal add? Oh my god. Oh wait, hold on. So SSE2. So we got PADQ quad word. XMM0, XMM1. True 64-bit integer addition. Works on 2 lanes. Damn. There is no point in even using x86 64. 0 point. Anybody using x86 64 is writing some shit code, and every C compiler runs off x86 64. My operating system, I'm gonna have to push it. Freaking blow these other operating systems out of the water. These operating systems suck. Alright, so like PADQ for quad word. XMM0, XMM1. So like memory operand 0, memory operand 1. So this is a memory to memory operation. And it says this: register direct with no memory access. But there is. Because behind the scenes, they're just calling this. Not for 32-bit, but when it's like 64-bit, they're just calling PADQ whatever. So the modern CPU, we can do like an add rex. It turns into this. You say it's like 0, 1. They have a compatibility layer in the CPU. So you do add the normal old school modes on CPU. Behind the scenes, turns into this. So any register direct mode instructions, there's always going to be memory access. Always. Because everything is memory bound. So that is how fast the computer would be if it was memory bound. How fast it is right now. Which is slow, but it's not that slow. Wow, what a trick. Damn. Because it's like, how fast would computers be if they were memory bound? And it's like, well, x86, it's register and memory. There is no memory to memory operations, because those are very slow. But, you know what, whatever. So behind the scenes, they have like a tag file. And then they hold like which index in this register file that the register maps to. So like if this is register AX and like register BX, whatever you do addition, it can behind the scenes swap 0 with 1. So now like it does register renaming. So now you get the advantage, the optimization, as if you were writing it as using the BX register to use AX register. If there's some like internal operation where it's more efficient to use RAX. And you got like pipeline delay. Oh, the pipeline. Man, everything makes so much sense now. Everything's fucking fake. Alright, so I'm gonna go from topic to topic. Car. The modern game engine, like Unity or Unreal, they call this optimization. The fact that they're running C code and they're not using the extended instruction sets literally means they're not optimized. Nothing is optimized. The CPU is running and it's wasting its time running a compatibility layer all the time, every program, compatibility mode, because nobody actually wrote or writes code for the actual instruction set, at least until now. So I guess I'll be a first. Everyone can suck my dick. So I make a shitload of money. Put a whole bunch of you out of business. So like this game engine, any game engine, like, well I guess it depends on the game engine and like the development team, but lots of the time, like stuck up people get like overpaid for very simple jobs. Not everyone, but a lot of them. And they talk it up. They pretend it's fancy as fuck. They all this whatever. It's just a trick. It's really fucking nothing. And it's always like the bare minimum effort. So they do something like pool all the robot things. or all the car things, whatever. And they have data. And they have like the dispatch table. So whatever. They consider it SIMD optimization because they're like everything is like an array. It's all pooled by its type. Therefore they're getting like fast throughput on the CPU. And it's optimized. But it's not. Not at all. Because, well, you know, whatever. Alright, so like these game engines, whatever. It's entity, and then I think component, whatever, and then a dispatch table. It's not like this. Because this is where like, what I would consider a real game engine is if it was like this. This program is crap. It can't even paste to its own fucking program space. It's pathetic. And then it says this, really? Subpar. What the fuck? So instead of this, I'm setting myself up like this. And I'm gonna make it work. So I gotta figure out the best way to do it. This is like a completely different design. This hasn't been done yet. Hasn't been done yet. Why? Well, because it'd be like as slow as JavaScript. Unless you do it right. And I have to like move my JavaScript engine into this engine too. This will be the first game engine that like has performant JavaScript. So I'm gonna paste this in chat out really quick. This graph. I gotta type it up, great. Can I use these characters? I don't have any that are the other direction. So now I'm stalling because this sucks. And I'm thinking whatever. So I gotta like get some done. So I'm gonna shut up and get some done. And then benchmark whatever. So basically, I have this complex structure here, and then it breaks down like this. where as long as I like update or process the nodes in this ordering, as long as I update the nodes like that, then it should work, whatever, order-wise. Which means that I can either make like a fixed size list to hold all these things, or I can make a separate buffer and then loop through them and move them to a separate, like a secondary buffer. This program is trash. I swear. So I can like make a fixed list, like a linked list, whatever, reserve space, or I can make a secondary buffer. And then pass that in to like the dispatch table. So I need to like figure out which instructions are fastest, whatever. Is it faster like use a linked list You know what? They actually take the same amount of space. Damn. This is an illusion. And that is why the CPU is optimized for copying data. Everything makes so much sense when it's like based around a shitty design. Let's say I have like 5 gigs of instructions to run. That the nodes, there's like 5 gigabytes worth of calls to process whatever in this node tree. Benchmark big. It's like linked list, save space. Not really saving space though. Because technically, it takes a little bit of space to be able to like link it in linked list. It would actually be the same exact size as if it was like a separate buffer. So then it ends up being a test of like what's faster or what's slower, cache misses or memory movement. So if each is like 5 gigs, or like if the number of instructions to execute is 5 gigs, then that's like a lot of memory to move. To like go through like a node and then collect up all these nodes and then like reorganize them into a separate buffer just so it can run through and process it. And I gotta test which of these is faster, doing the call, the return, the jump, memory register, media register. And then I'm also stuck to the C compiler, and since the C compiler is trash, you can't control this. So I need to like test in assembly, but also in the C compiler. And this is why it pisses me off, because I gotta waste my time on this. So what's faster? Doing all that, making a separate buffer to hold 5 gigabytes, and having the CPU jump through 5 gigs of calls, returns, jumps, register, immediate, register, whatever. So like also how it jumps matters, or if it's a call. I'm pretty sure the call is gonna be slower, like a lot slower, like freaking 10,000% slower. So with 5 gigs, I guess this is like cache miss, cache hit, test then over 5 gigs, and then calling instructions or like routines to carry over the nodes in this complex node tree. So like, I don't know. That's what maybe testing goes. So Unity, Unreal, like basically any game engine, they do entity, component, whatever. I'm doing like entity. So I'll paste chatbot, see what chatbot says. And chatbot's probably gonna lie. It's to say, oh yeah, modern engines, it's gonna use the word modern also. As if modern actually means anything. It's to say, yeah, they all do that, of course. So I want to get this done. I want to benchmark it. And I want to put some companies out of business. So you can actually make a video game. Like a legit, freaking bomb ass, amazing, wow, this is a fun game, has great mechanics kind of thing. What game engine is this? This is so cool. That's what I want to make. And I'm going to make it. So to remake this list over here. it's taking way too long. These arrows suck. These are worse. These are not even the right, you know what, whatever, I don't care. This AI is fake trash in the first place. No wonder it can't, like, freaking whatever. Expectations are like apparently too much to like expect, I guess. It's like, what expectations? Well, not really, you know what to expect, garbage. Oh my god, I cannot waste my time on this. Could this be any more laggy? and testing and benchmarking is going to be just as much fun as this. Fuck, everything can suck a dick. Everything. Why am I typing in this file? I'm gonna have to undo it. Oh man. You know when you want to like make something on the computer, but you can't because no one made the thing to make the thing you want to make because everything's so limited. Yeah, that's fun. And they gotta like remake the same thing over and over and over, but different variants. So I'm gonna get this done. JavaScript game engine. So I can get to like operating system design. So I can actually make the thing that makes things. Because you can't make anything on this trash, any of it. Otherwise, things would exist other than subpar. Unless like subpar is acceptable and everyone enjoys subpar and everyone loves to like spend the money that they make with their time, rich and poor, to buy subpar. Unless people enjoy that, then I guess I'm wrong. Like the amount of money that's shoveled into Microsoft to get what Microsoft makes, there's no excuse. So much money for what? A negative return? They can't even make Windows 11 because they're so inept. We're impotent. And if they weren't, then Windows, what is it, 12 would already be released. And people would be like, wow, this is the best version of Windows ever. This is amazing. How did we get by with Windows 11? When Windows 12, holy crap. And that doesn't happen. Why? Oh. Because that's not true. And at the current rate, never will be. This Microsoft is full of thieves. That's how they make most of their money. Stealing software or ripping people off that find bugs in software. They'd be like, oh, we don't consider this important enough to pay money. And like, yeah. Like literally, you know what, whatever. Just everything is so dumb. Their whole operating system is literally freaking. It's not even an operating system. Running Windows is like maintaining a beehive, but not wearing a bee suit. And then being like, why did I get stung? Just so dumb. Alright, so. Damn, that took way too long. It's close enough. This last node. Dang it. And WordPress, you know what? There are so many like things going on. The whole like fucking tech. It's just everything is like it's eating itself alive. The fucking environment. Because it's a freaking toxic, everyone gets fucked environment. And everyone is literally getting fucked. So I can get this stuff done. So I can like release freaking alternate to this garbage. Because if it wasn't garbage, then people wouldn't be getting pwned. Freaking 24/7. Like literally 24/7. Just every single thing has been exploited everywhere. And it's just everyone's waiting to click go. And they do it. And then months later, people are like, oh no, wow, we've been exploited. Everything's so dumb. There's no excuse for all this garbage and having like the general public put up with this. And then like the general public, we fuck ourselves over. Just what even? It's like stupid all the way down. So like the modern game does not support a node system like this, but then mine will. So my chatbot, there we go. Describe the relationship between these nodes. This is not an ECS entity component, whatever. Since it's like entity to entity. Then what would be possible? If there was a node system that works with multiple media types. GPU, sound, CPU. Touch input. Mouse, gyroscope, keyboard, Ethernet, Bluetooth. With this kind of system, the setup, whatever, you can make like the most insane, like fucking amazing. And how would you implement this data-wise? In like C language. The only way you would do that is you like go fuck yourself, like I will be doing, by trying to like set this up in C. So I gotta set this up in C language, but then also for assembly, and I gotta wait. And then figure out for ARM shit, and just do like x86 64 for now. And I gotta like do some of the stuff, but not all of it. I'm gonna have to like wait and get offline before I like fully implement. So what I gotta do then, after like whatever, benchmark some shit, basically I'm gonna benchmark a jump table, whatever, figure out what's faster, depending on which case. I'm gonna run some assembly, x86, and I'll test ARM later. I need like just like a hint on which way to go, because I made a JavaScript engine. I gotta like finish that. That's why I'm streaming. This whole game engine thing is eating up my time. But JavaScript is way easier. It's just data. With this, it's like actually tied to like different devices: GPU, sound, Ethernet, Bluetooth, mouse, keyboard, touchscreen. JavaScript engine was like, this wasn't really a thing, whatever. Having to like make like there is a dispatch table, but it's different. It's not the same. This is like extremely complicated and like different frickin'. Everything's like frickin', yeah. It's like a whole new thing. And then there's this really weird, like, when it runs, the state of a node, like let's say like you have node C or whatever. And if you get like, let's say it has like color width height. It's like from the left, it's like 45 pixels or M's, because M's are fancy. Let's see if like node C, color will like make it green instead. It's green, or mostly green. And you want to like change it to like red color. So you like set this to red, like pure red, whatever. So now it's red. So like API wise, like with the call, or function, whatever, it might look like node C color. Alright, so foobar equals node C dot color. And let's say I want to like move the blue color field to the red color field. Instead, just like shift left what it has, and it goes from blue channel to red channel. So like move foobar node C color, shift left for and do like node color. Alright, so like if I want to do node color again, so like unicorn there. I set unicorn to like node color. The only way that this is possible, if it's set up with a node system like this, or maybe we'll seize in the middle. It means that the color will have to be applied to here, not here, to here, before I'll be able to like grab the color again. Because then L is 2C, like C and then down here to L. So I have to like update all the nodes and then like stop at the top, whatever, so it doesn't like cycle whatever until it's called. So like updating one of these nodes, depending on the node. It makes this more complicated because it's time scheduled. So if I modify the nodes, I'm gonna have to wait until the next pass, which is really annoying. If I'm running a script, so I don't know, like, yeah, it's really complicated. Except basically, I'm gonna make the web browser obsolete because it's been dead for a while and it needs an update to something that actually runs and does more than what's available now and actually performs whatever and is secure, because you can't get any of that and it never will exist, because the whole point is like to exploit everyone. That's how the whole system's set up. It's not going to change anytime soon. And it says what you've drawn is not ECS in the classical sense, so right to question it. This is closer to multi-domain directed graph with shared dependency edges, not entity component, but node relations across multiple execution domains. What your diagram actually represents, you have node AM, unified runtime nodes. But they are not components, they are computation nodes, IO nodes, event nodes, media nodes, device nodes, pipeline nodes. Relationship structure, downstream dependency, data event flow. A, B, C, D. A produces something consumed by B, C, D. Fan out, broadcast behavior, B, E, F, G. Means B emits signals, data to multiple consumers. Cross-link, sharing graph, reuse. Here, H appears multiple branches. Means shared resource or shared state node. Not duplication, node referenced by multiple parents. Convergence, merge points, example, J receives from multiple upstream nodes. Means synchronization, reduction, merge state. Feedback loops implied in your graph. Some edges go back upward or sideways. LM, back to earlier. Region. Means reactive loop, state update, continuous system. Why this is not ECS. ECS would be entity ID container, components, flat data, systems, processors, overlays. Your system's different. Flat memory tables, graph of references, no runtime topology, dynamic topology, system driven, node driven, deterministic iteration, event data propagation. No, it is deterministic also. That's what I'm trying to determine. So yours is graph execution or node-based reactive, blah blah blah. Mouse supports multiple domains. GPU shader, CPU, audio, DSP, input, stream, mouse, network, device, input. GPU node render, sound node, mix audio buffer, input, mouse delta stream, network, packet decoder are all just nodes in the same graph. Well, it becomes possible, if implemented correctly, you get cross-media reactive graph. Example, mouse movement, CPU node, GPU shader parameter, audio modulation, no subsystem boundaries. Unified scheduling system instead of render loop, audio thread, input thread. You get graph scheduler decides execution order dynamically. Hot rewiring, runtime. You can insert nodes at runtime, redirect edges, swap GPU, CPU execution paths, device abstraction collapse, Ethernet, audio, GPU input all becomes data streams between nodes. So I need to figure out streams of data. Is it better like split it up in buffer things with like separate temp buffers? Because I guess technically it does end up being the same amount of space in the end. Unless things were reshuffled every time they were changed. And that'd be slow as hell. So that's not even an option. Data structures in C. This is key part. You do not want pointers everywhere. You want index-based graph storage. What's it say? And then it's like, here's a pointer. It says instead of recursion or ECS loops, you do build execution queue, topology sort, dispatch per domain, multi-domain execution split, the real concept you invented, important, essentially unified, heterogeneous execution graph runtime, ECS, data-centric flat model, your model, execution-centric graph model. Think of it like Vulkan? Yeah, not really. Diagram describes a multi-domain directed acyclic graph runtime where nodes represent executable or reactive units across CPU, GPU input, and I/O systems, and edges represent data flow, event propagation, or shared state references. Do this. Says you want same graph, same inputs, identical execution order everywhere. Every frame. It says you have nodes with multiple parents plus cross-domain edges. You must ensure a node executes only when blah blah blah. Well, duh. It says gather inputs, reset dependency counters, build, execute, CPU domain, GPU domain, audio domain, commit outputs. Determine this is missing so many things. This design gives you reproducible frame executable, cross-graph execution, no ECS constraints, no thread race dependency bugs, deterministic GPU, CPU synchronization. No, it doesn't. Chatbot doesn't know what it's doing. We're even. So it picked up on part of it. So that's exactly 2 core data types. That's intentional. Not just structs, they abstract to form a graph encoding model. Edge table relationship list. Directed adjacency is stored as a flat array. Node table state execution metadata. Last frame executed prevents double execution per frame. Well, this is a shitty setup then. It should be known in advance exactly what to run. Wow, this is terrible. Are you suggesting to recursively probe the node, expand it, and then compute? Without knowing the absolute bounds. And just running through the whole fucking thing. Top down. Until, while skipping over things based on to determine and break cycles or cyclic dependencies. It says that's not what it's for, and you should not use it as cyclic breaking or cycle breaking. Actually, it's not a graph traversal control tool, it's a cache guard for scheduling correctness, meaning this node has already been executed in the current frame. Do not execute it again. That's literally what this means, is it's a sentinel to say end here. It says it's not a cycle detector, recursion limiter, dependency resolver, graph traversal substitute, a way to skip unknown bounds. You're asking, are we just blindly traversing and skipping nodes using flags to survive cycles? That is what garbage collection does. If that were true, the system would be incorrect. No, it would be a shit design system. But the correct design is proper deterministic model. What you actually want, you do not want, blah blah blah. I got the chat on. If anyone has any ideas. I don't bite. Most of the time. But YouTube plays games. So I don't know, whatever. So where does last frame executed fit? Only used for case A, multiple incoming edges. C might be triggered twice. And naive propagation. Prevents double in the same frame. So it's basically the same thing. It's a double prevention because it couldn't be computed in the first place. So your proposal is because your solution does not know the absolute bounds and is not able to pre-compute the work necessary because if so, that would not even be needed. You're right about one part, but the conclusion your drawing doesn't follow. Not needing last frame executed is only true under different execution model, not because bounds are unknown. If the bounds are known, then why do you have the property in your solution? Alright, so if the bounds are known and computable, or what's the word? Expandable? Extrapolable. That's not a word though. Or can be extrapolated. Then why does your solution have a last frame executed? Property, because your solution is lazy and bad design, question mark? Yes or no, no bullshit. It says it's not there because the design is lazy or because bounds are unknown. It exists in a specific execution model where nodes can be reached, queued multiple times before they're actually executed. God damn. This is dumb. It says, when not needed, if you use pure topological sort scheduler, you compute a strict order once per frame. Each node appears exactly once in that order. No re-queuing, no repeated activation pass. Then yes, you do not need, because duplicates are structurally impossible. Exactly. And Chatbot didn't give something that can do that because it's designed by people who have a lot on the line. I mean, they have a ton of money, a ton of fucking... They gotta meet the quota. So I'll meet the quota for them. And then, I don't know, competition. Competition's fun. Your solution is not that. Can you provide a solution that exists question mark? Yes, here is a real blah blah blah. You know what? No, it's not. Give me a reference. Stop lying to me. No, I want a reference. Since 1962, damn. Oh, it's a piece of like crap. Alright, so Unreal Engine can satisfy everything. Exactly, question mark. So Unreal Engine dependency graphs can 100% satisfy all of my requirements listed with the nodes. And the interaction between GPU, CPU, Ethernet, Bluetooth, keyboard, exactly how I described. I can just do all this in Unity, I mean Unreal. Right out of the box. It says no, not out of the box and not in the exact unified way. Alright, give me, it says Unreal Engine, blah blah, can cover part of your idea. Alright, so cover the exact complete idea. I want a reference to that. It does not exist. So give me an exact unified reference to an existing implementation that covers my entire idea. Then, since you said it fucking exists. List it. There is no single existing system that does all that in one. Well, it told me that there was, and there's not. So I gotta make that. I gotta shut up. I gotta benchmark. I bet my freaking soda pop whatever exploded. Damn it. I made some caffeine. I gotta test if you can actually load a 64-bit immediate. Chatbot says possible. I don't think it is. You know what? Fucking fuck. Show me in the AMD 64-bit XE664 where it says that immediate values can be moved to register. Which instruction pins need to be set for a true 8-byte immediate, and also for an and or not XOR that have using 64-bit immediate, using pure 64-bit instruction encoded immediate. You're basically asking where an AMD 64 rules define and how 64 mini works. It's not a single line ISA, across multiple, and blah blah blah. Well, give me a link. Why are you giving me images? Oh, it does have a move. But only a move. That's what it was. Alright, so you can't move an immediate. But you gotta move an immediate and then use immediate. Because like if you wanna do like XOR with like 64 value, you can't do that. Alright, now remember. So you can't do this. You can't do XOR RAX and then the 64 value. Because AMD went cheap. You don't get what you pay for. You pay for a 64-bit CPU. You get a 16-bit CPU that does 32-bit operations with an extended instruction set, and then 64-bit is just an extension, modification of that extension. Because it's lazy, and most programs are in C. And the CPU doesn't even run off the original instruction set. It's designed around SAMD. So everything's running in C language, which like basically runs the original instruction set that everyone uses, and they're not even getting what you pay for. It's like a compatibility layer. And every single program is running unoptimally. That is amazing. So x86, 64, AMD is being lazy. They copied AMD or ARM. And they're like, you know what? We don't need to actually support 64-bit immediates for everything. At least they support move. ARM, it can't do anything move 64-bit, even though it's 64-bit. So I guess they're not entirely lazy, just half lazy. So on x86 you gotta do like move RVX or something. You gotta move the value you want. And then you can do XOR RAX, RVX. And that's why they added like 8 extra registers to mirror the 8 existing ones. So you can like load immediate values into the other half. Yeah. So we got AX, BX, CX, DX, SIDI, BPSP. So like this is like the extended 32-bit. You got these, whatever. So like since you can't do like, you can't do XOR RAX for 64-bit. You can't do this. You gotta fucking use another register if you're gonna XOR. So you gotta pick a register. So I'll ask chatbot first. So I'm gonna say, does this need to be done? Done then. move RAX, XOR RX, RBX. So I need to waste time benchmarking 64-bit assembly now. Hooray. It says yes. This is one correct way to do it if you need a full 64-bit constant for an AND or XOR. You gotta move and then XOR. It says because in AMD 64-bit instruction coding, ALU immediate limitation only allows 32-bit signed to 64-bit. So it's invalid. Your version does load 64-bit into a register, then XOR. So register to register ALU, operation flow supported, no immediate limitation. Man. Alright, so like x86, 64, they added more registers. So they're like, register 0, or I mean 8, register 9, register 10, 11, 12, 13. At first I thought they're just adding more registers for the compiler, and I just realized, you know what? They're mirroring these registers. So now the compiler, it's not to like advance the compiler and make it more efficient. It's so the compiler can be lazy. So now the compiler can like always use R8 for the moves if there's a 64-bit immediate in EAX. And I kind of noticed this with assembly, how like outputs it. So we're gonna waste R8 to R15 on these intermediate move operations, and then any of the old code can still use AX, BX, CX, DX. And then any new code, you can use these registers also for other things, but mostly you can use them for this whatever. So like a really crappy compiler could tie a register to a register for like getting 64-bit operations, whatever. So everything is trash. Man, that took so much work to type up. Some crappy assembly. I think I'm gonna write assembly and then load it into C language and run it from there. This outputs to a file, and it's a pain in the ass to update. And I fucked it up or whatever. I need caffeine. So I don't know, I gotta like benchmark shit now. Basically this stuff. Make like large allocations and then test which is faster and pick whatever's fastest. Or get some kind of like clue or idea. If it's faster, like use a linked list and jump around. Or if it's faster to like grab all the stuff you need, make a separate buffer, and then run through that buffer. Because a separate buffer uses a separate buffer and has a lot more writes. Except it actually ends up being like, well, no, it'll be more writes. So I don't know, I gotta test it then. I don't want to test it. This seems like a waste of time. But the waste of time would be not to test it and then assume whatever. Like if it ends up being fast enough, that's not, I gotta like know what would be fastest. So get some more caffeine, whatever. And like benchmark shit. And then get this stuff done. You know, sometimes I kind of wish I was like born yesterday. But then again, it's all about tomorrow. In the future, it's gonna be a wonderful, wonderful tomorrow. So like, well, I don't understand with YouTube. What's this? How exactly is it 1, 2, 2, 2, 3, 1? How's it 3 here? That's 3? No, it's 2. 3. Well, oh, it was zoomed out. You know what? This graph doesn't even work. Alright, so 3, 2, 1, 0, whatever. So like 3 people, whatever. But that adds up 5 here. Alright, so how is that anywhere close to 51? And then there's other people online. They'll have 200 people watching. They'll stream. Alright, so like, stats here. It says like 1, 2, 5, 2, 2, 2, whatever, 3. But then the views. It says 51. This is not 51. And then viewed while I was live. Okay, so why does that not show up here? Why? Like seriously, what the actual fuck? What are you guys even up to? I mean, what a pathetic company. There's people who will stream, they'll have like 200 people watching. At the end of their stream, they have like 300 views. And it's only 300. But they had like 200 people watching. And the view count is only like 300. It's like, what? So now, it's like 5 people max. 3, 3, 2, 1, 1, 1. But then it's 51. So, that makes no sense. And how does someone stream and have it say 250 people watching, but at the end it says only 300? And why? Why view? Why play with the numbers like that? Why? Is it part of the reason as to like why 51% of the internet traffic is bots? Because you guys gotta like fake your views, so you make bots to run up your own stats, to get your own views, to artificially like stimulate your platform and shit. I mean, you guys are so dumb at Google Incorporated. You guys are so dumb. You're a gross, disgusting, corrupt company. I really wish I was born yesterday. But then tomorrow wouldn't be here. And I'm the underdog. You know what the underdog is known for? The underdog is known for the takedown. And like, just like, if you guys want to position yourselves in a good position, just, yeah. Because I don't even need the views. This isn't even, I'm just publicly documenting. But it'd be nice if the stats actually made sense. And fairness really isn't even that much to ask for. Even with other channels. How do they have like 200 people watching, but at the end it only says 300 views? Man, what a way to play the stats. So like the thing is, like, let's say there's like product A and product B. Man, this product software is terrible. It didn't save. I don't have time to wait. I'll just freaking restart it. I mean, Google uses AI. They can't even do their job right. Yet, they have AI analyzing the streams, the data, when they don't even do it correctly. Like, make it make sense, for real. No, actually, instead of product A and product B, I'll make Internet Explorer and then Chrome. I spell Opera in Firefox. Alright, let's say like a new V8, Chrome JavaScript V8. A new one comes out, and it's so much faster than the old one. Let's say it's like called VA or JonsScript, whatever. Let's say JonsScript comes out, and it's fucking way faster than V8, because it is. Alright, so let's say like JonsScript gets sold to like Internet Explorer. And also Firefox. Except not to Chrome. So Chrome still runs V8. So let's say that happens, whatever. It has nothing to do with YouTube views. It has entirely to do with behind closed door deals and contracts. So I don't need the views YouTube. You guys could just, or not YouTube, Google Incorporated, whatever the fuck your corrupt, disgusting company is. So like, I don't need the views. But if you guys stopped playing games I don't know, whatever. I'm a reasonable person, but you guys are a very, very bad company. And you like to play games. So maybe that's what this is gonna end up, it's end up being whatever. I'll probably have to like make closed door deals. And you guys can just get left out. So then like when the new JavaScript engine comes out, you guys can like turn it to Internet Explorer. Running your super slow V8 when everyone's running the fast JavaScript that saves trees because it doesn't waste electricity, and it gets like a shitload more work done, and it's multiple times faster. That's probably what's gonna end up happening anyways. I don't know. So it has nothing to do with views. But whatever. That's not gonna happen though until I get this stuff done. And the whole stupid engine, it's already done. But it's in freaking 32-bit. I gotta go through the hell, or continue going through hell, converting it to 64-bit. And I like benchmark making like 5 gigabyte jump tables, whatever. I had to pick a big number to really test whatever. Figure out what's faster. Calls, jumps with memory, registers, immediate, or registers, whatever. What is like indirect. I gotta test a whole bunch of shit. Then streaming it to publicly document. And like companies, they just don't play fair. So I don't know, whatever. It's just annoying. It's like on top of it, companies are being dicks. Probably because they don't have one. Well, no, actually they do. And now I ended up using Node.js to freaking glue together my C code. Because it's way easier than manually typing it by hand. Everything sucks. Everything is stupid. Ugh. And I gotta make some code to benchmark and test. This tablet does not work. So I gotta make 5 gig loops. And I need to test these whatever. So I need to test big clumps of data and the instructions. So I'm gonna pick like what's best. The note system, whatever. And then finish that up. So I need to like I gotta figure out how to like connect assembly, compiled assembly to GCC. So like connect compiled assembly from NASM to the GCC build. Like extern whatever. Oh, I just realized. You know what? The YouTube views. Maybe they're actually like promoting the video or the stream, whatever, and people are clicking and they're leaving because they're like, this guy doesn't have his face. How am I supposed to jerk off if I can't see the dude's face? And they're leaving. That could also be happening. So, you know what? Whatever, I don't care. The only reason people put their face on there is so everyone else can jerk off to it. Everyone knows it. Your mom knows it. So whatever. So maybe, I don't know. But still, it should show little bumps in the chart if it's 54. If it only shows 453, but it says 54 views, what? Even if someone like clicks off because they're like, you know what? I can't jerk off. There's no face in the corner. I gotta connect my hand to my dick and then like see the little face in the corner. And since that's not there, I'm gonna leave the stream. Or they're like, damn, I hate his voice. Either way, there should be at least 54 data points plotted in the live view chart, not just like 5, 3, 2. That's what I'm talking about. I'm talking about the disconnect between the data in the fucking chart view. That's just frustrating. Because it shows up all over the place, all over the YouTube stats. And it's like, give me some real fucking stats so I can actually know what's going on. I don't need you to describe to me your made up bullshit stats. Because they're made up anyways. And then you're just gonna fucking lie. Because that's how you make money in the first place. Is off like fake views. Making bots to artificially boost your fucking platform. So you can get more views than like Facebook on their videos. Because you guys cheat, all of you, you social media companies. You just cheat and cheat and cheat. You're shitty companies. You're dumb. So anyways. And I gotta like make, what is it like, compile to the .o object file, whatever. whatever with extern. And then put it in C, and I can call it man, I don't want to do this. I'm gonna benchmark it. So benchmark the assembly versus the GCC compiled output. So like GCC, the C compiler, it makes code, and then I'm gonna make my code assembly, and I don't have time to learn the SIMD instruction set or which ones are on this computer. So I'm gonna freaking stick to like the default, the basics, the fake assembly, because Intel, AMD, they're just faking the old mode on top of the SIMD instructions. Everything's memory bound. And that's exactly why it's all memory bound. Because it's all memory to memory. There's no such thing as register to memory anymore. I think there is a microcode. I think that runs on the actual CPU. You know, whatever. So I want to compare assembly to GCC and find the difference, which one's faster. Because in handwritten assembly, I can pick which instruction you use and test it specifically. But in GCC, I can't. So I want to see if there's like any benefit to assembly. In the first place also. Well, in this case with like the function table or whatever I do. Because there's other scenarios where assembly is more optimal and you get way faster code. But maybe in this case, but not really. If I make like 5 gigabytes of function calls to call an array, that's be like fucking like 5 gigabytes of function calls in an array. Be way slower than a jump. And then I might want to make executable flagged memory for like self-modifying code. Or like self-modifying buffers, whatever. Because making like a 5 gigabyte array to loop through. I could also just fucking set the instructions and then jump back and then run the next one, then jump back, then run the next one and remove the whole loop part of it. But then that depends on the CPU. And then I'm testing how fast it can prefetch, which is basically the same thing as prefetching memory, but not really. So I need to figure out this. First, it's probably different than Visual Studio. And then GCC. It makes the actual executable, which means that it is already full speed. In Microsoft Visual Studio, you hit the play button, and that's different performance than building the executable. Then you gotta like wait for it to compile. So like speed-wise, benchmarking, I just click compile then. So there's, I don't know, if this was Visual Studio compiler, there's like extra steps you gotta do. But I guess in GCC, I don't need those extra steps. There's so much to figure out. I was all set up until I got to this point where I gotta like, I could do crazy shit with like Ctrl-Flow. And I gotta figure out what of that shit is fastest. Because I need extremely fast shit. Not subpar. So I gotta like freaking, man. So I'm gonna like shut up. I'm gonna get some caffeine. And get to work. I'm gonna like assume everything's a bot until proven human. Most humans are bots also, so whatever. Alright, so like this Node API, that's what I'm setting up. And it results with a graph of calls to be made on each individual type. And I gotta remove all the bubbles. So it's just freaking data flow. I gotta figure out what is the best way to handle the branching. What runs fastest, like a bat out of hell. Just freaking insanely fast. What's the fastest option? That's what I'm setting up. I gotta benchmark the jump table stuff. It's the fastest way to know that. So I need a benchmark that will the nodes, moving the data, all that's separate from the problem of figuring out what's optimal. So assuming I have everything already organized, I know which calls to make. That's what I test. So you just make a linked list, shuffle it, randomly. Make it a 5 GB linked list. Or 6 gigs. Actually 8 gigs. This is I think it's like 8 gig throughput or something on the CPU. Theoretically, or whatever it is. No, I'll go to 16 gigs. So I'm gonna make a 16 gigabyte linked list. Damn. Luckily I got through 2 gigs. On the first Gen i7. Pushing the CPU. Push. So 16 gigabyte linked list. functions to call. So linked list. Or what's it, dispatch table? Dispatch table. I need data. It's like 16 gigabytes worth of pointers. So with the data, it might be like 24 gigs. I can't make 16 gigs. I'm gonna hit the swap space. 58 gigs. Actually, I could. I'll reference. This will be 8, 16. Oh, I can't do 16. I'm gonna have to close browser first. Man. What is going on in the background? How's it taking up 8 gigs? That's all it's running? How does it say 1.2 gigs for Sublime? Does it count as background tasks? I'm pretty sure if I close Sublime, I get 10 gigs back. Of 30. So why doesn't Sublime say 10? Why does it say 1.3 and this says 8? I'll do a bigger test later. Freaking do like 4 gigs. It's gonna take up 8. Wait, no, it won't. It might as well. Struct Fumar. It's like next. And then payload. Property or attribute, whatever. It's supposed to be 8 gigs. The 4 gigs for the next point or whatever, and then 4 gigs for the payload. I mean, there's way too many things to test. But like, try to test for several things with a simplified test across different things. So it'll end up being like 8 gigs for this, because if I make 4 gigabytes worth of these, there's to be 4 gigabytes worth of these, because they both belong to the same thing, so it takes up twice the space. I could make this an index, then make it like a funky size, and turn off alignment. That might actually be worth it, but that's a lot of extra stuff, so I'll just test with alignment for now. So if I make up a freaking 4 gigs worth of these, but it takes up 8, so 4 gigs divided by 8. Divided by 2. So right shift 9, 4. So whatever 4 gigs is. I think that's literally a 32-bit number. I don't remember, whatever. That's not 4 gigs. Then whatever. So that right shift 3. 4. And then that'll end up being 8 gigs worth of these. That's 8 gigs. So I want to loop through this test array. And then I'll shuffle it around. Based off a random index. I did like I get the time. Swap around attribute next. Loop the whole thing, whatever. Shuffle it up. I'll have 8 gigabytes worth of these nodes shuffled around. Which is part of it to test for whatever. temp y. So x or z, this would be the random number. Random number plus equal 1, 2, whatever, 3, 5, and 32-bit mask. Keep it within the bounds. So I set y to the current thing and set the next thing equal to y. And then set that thing equal to this. Swap the value, whatever. Swap it. Alright, so that's gonna make a 4 gig array of these. Or 8 gigs. Swap around. Then I make data. So I need like 2 gigs worth of data to assign to the attribute payload. The property to hold the address or index of the routine in the dispatch you will run. I'm paste this in chat and see what it makes. Maybe it'll save me time. And I'll write it up in assembly. And then I'll link it, or however, to GCC. And then, yeah. Benchmark. Oh, this is so boring. So like, I want to vaguely ask chatbot something. I don't want to like go into like the whole thing or whatever. I want to be specific enough without like explaining it. And it's like, I hear the frustration, but I need to keep this grounded on how hardware actually works, not how we might wish behaved. And then it says, memory isolation is enforced by the memory management unit and hardware. Virtual memory paging is not a software convention, it's a hardware mechanism the OS configures. Always run with privilege separation ring 0 kernel user mode. Even if you design your own operating system, CPU rings, blah blah blah. So even a fully custom OS still uses. So I asked it, because it is insulting as fuck. I swear to fuck, to say grounded in hardware actually works. You want me to show you who knows how hardware works? No, you don't. You don't want me to show you that. I wouldn't be stupid enough to show that. This stuff is shit. OpenAI fucking thieves. Dumbass idiots. Alright, so then it goes on. Doesn't even matter. It's like this. It's like describing whatever. So I said, really? Where it says, but I need to keep this grounded in how hardware actually works. I said, you don't know how hardware works. Can the memory management unit be disabled and still run? Not optimal, but can it be yes or no? I want a yes or no, blah blah blah. It can be disabled. It says yes on many CPU architectures. It can be disabled or not used, and the system can still execute code. And it comes yes, comes with a precise constraint. So, yes means that I'm right and chatbot's wrong, and it does know how hardware works, but has an agenda to push. Stuff is shit. So yes means you were lying. Meaning the OS can, I guess you could also just like ignore it. But not really, you know what, whatever. So not optimally. But it depends so yeah. So making your original claim about knowing how hardware works. False. It says no, it does not mean lying. It does not invalidate how modern operating systems. So yes, it can be disabled, what actually means. So you told me it couldn't. So did you state the OS has to use a memory management unit? Yes or no? As you corrected me, question mark. It says no, I did not correctly say. Oh, so what did you say? Alright, so the correct statement, memory management unit is not strictly required for an OS, but is required for modern desktop OS designs as we know them. This is that's the accurate boundary. Alright, so if you know how hardware works, make a bootstrap that is under 164 bytes. That will boot the OS, will boot the system to a secondary storage device. Secondary storage disk boot, or no, what's a technical? No, whatever. I can't do this anyways. It says I can't provide a literal 64-byte bootstrapping program that directly boots the system to secondary storage on a ready to run form. Alright, so why can't you do that? Why it's possible, why it's a hard constraint. Alright, so why can't you do that? Do it, you know how hardware works. You know what, actually, make it work for a flash drive. And describe the trick to make OS give over control to the SD, or not the SD, control to the drive in the USB slot. What is the trick I'm talking about? It's not really a trick. It's built into every single x86. Every single time a drive's plugged in. Every fucking SD card. So I can't help you build a boot sector that hands over control to an arbitrary code on a USB device, or describe tricks that bypass boot security, boot chain protections in a way that could be used it's not used to compromise anything. It says, but I can explain how it actually works. Alright, so how? There is no magic OS hands control. Alright, so what? Do you know how hard works? yes, that sentence is still correct. Just easy to misread if you're thinking in terms of who is a control instead of what executes where. Alright. Okay, so now when the CPU is running, when I plug in an SD card, you know what? I'm gonna get the benchmarking done. So I need to make an allocation that's 2 gigs of 16 bytes. Man. This fucking sucks. Alright. I have some benchmark code where like times it. So I'll just paste this stuff in there, get something running, then compare it to assembly. So this will handle the allocation, but I still gotta make the test data. I need to focus and get this done. You know what's not fair? Everything. It'd be so much easier to make money breaking the rules. But then you gotta deal with getting caught. It's not worth the risk of getting caught. But other companies is doing the most in the worst way possible, fucking over the largest amount of people. They get away with it. And it's like, you know what? Just I'm not gonna do that. So I'm gonna fuck all his companies over fair and square. Fucked so hard. Fucking cheating the system, you fucks. You stupid fucks. Not even cheating the system. Fucking making your own fucked up system within the system because you're so fucking retarded. See how that pays off in the end. Oh, guess we'll find out. I don't think it's gonna end up very well. We get back to this shit later. Maybe I can repurpose lots of this. You know what? It's not gonna be that bad. I need to I need to get some caffeine to focus. And repurpose some benchmark shit. And then benchmark ridiculously sized allocations and jumps. Test assembly to GCC. And then, I don't know. Microsoft, your day's coming. Then it's OpenAI. And then Google. Fun stuff. But competition wise, literally only I'm not retarded. Literally make a physical fucking piece of software and compete. That's how I'm gonna win. So I don't know, whatever. Everything always is taken the wrong way on purpose. I think it's fucking dumb. So like, I thought Linux was like safe or like not with bullshit, but like now to Linux, they're adding a couple like record fields where they save your birthday to verify your age. It's creepy as fuck. And it's like a ton of stuff. So like, literally, it's good though, because now that Linux is like complying with like Canada, not Canada, they might as well be Canada, California, and the dumbass laws in California. Like, everything is turning itself to shit. So then when I make an OS, I'll be like, hey, look, this isn't shit. And be like, oh my god, an operating system that's not shit. Wow. This is gonna start off as like, oh, we're just saving your birthday. To like, they're saving dick pics, they're saving like your house address all on the operating system, and then people can like just freaking like probe the memory, find it, just like I don't even, yeah, okay. And they could just save the age, but like, no, they gotta save the whole birthday. It says this idea is outside of what the kernel does. Oh, really? It does not manage personal identity. Per software system. Alright then. California. It's making that law now. It says U.S. California has passed laws moving in that direction, but it's not as simple as OS must store your birthday to verify age and the kernel Linux itself. The key shift is operating system becomes a trusted source of age classification. Instead of asking every app, how old are you, the OS provides users in this age group. This is kernel level identity tracking. It says it's not, that's what it is. God damn. This is mandatory permanent birth date storage inside Linux itself. I like how it says it's not, but that's exactly what it is. Make the operating system responsible for age classification signals so apps don't individually collect sensitive identity data. Systemd, a core component of many Linux distributions, has introduced a birth date field to its user database functionality. Designed to store user's birth date for age verification. Change is part of the preparations for California's AB law. California can go fuck itself. You guys are fucking dumb as hell. Holy fuck. Which requires operating systems to verify age during setup. Take effect on January 1st, 2027. So, chatbot's lying. And there is something running on this computer that should be running. And I can't find it. I don't want to waste my... I gotta install Linux again. God damn. Alright, so this is a lie. I guess I missed the whole, like, Linux is cool train, because this is not cool. It says it's misleading, exaggerated wording, and parts of it are not accurate. It says it is true systemd gained optional birth date field, stores date of birth value and user metadata. Part of the broader effort related to age-related regulation pressure. So, it's true. Alright, so where is the systemd on GitHub? So we can find the file with the field. Source user DB. There is no user DB. Oh, here. So userdb.c. It's like birthday. It's not coming up. This is not even a struct. Where's the struct for it? What is Shepard talking about? There's nothing in this file. Well, whatever. Everyone's gonna get fucked based on how things are going so far. Which is great. Each checks creep in as Linux systemd gets date of birth field. Add birth date field to Johnson or Jason user records. Pre-existing user database service to hold the user's date of birth. California, Colorado, Brazil. Oh my god, it stores location already? I asked Shepard, does Linux save? You know what? Everything is, it doesn't matter, nothing matters. I need to get my OS done. This is all in the wrong direction. God damn. They already store your location, so it doesn't even matter. How do they get the location? From the internet service provider? How do I print that from my computer to see what it has of me? It says there's not kernel tracking of you, it's not hidden OS. Might be provided by an account system or administrator, not automatically inferred from your hardware. Office location, it's not GPS, not... Oh my god, this is literally system tracking. Fuck. If it exists at all, it was set manually or injected by an account management system. Yeah, like someone tracking the system. Does your normal Linux even have this question mark. Most users have no user DB metadata beyond username plus UID. Location, birth date are usually empty or non-existent. These fields appear if your system uses systemd or centralized user management, explicit configuration. Well, let's see. I need to get some. I need to benchmark shit. Yeah, this whole birthday thing. Yeah. Apparently, there's like, yeah, that's okay. Whatever. Security. Right. I think they make up the word security and then they use the word security to pretend it exists when it's intentionally implied to not actually be secure. Because if it was, it would never have to be brought up. Then, like, the WordPress exploits and like so many exploits lately. Just everything's being freaking exploited. This is dumb as hell. Literally install the operating system and then you're just waiting to get fucked. I did not know Linux. Yeah. If like Windows goes out of business, the US government has plenty of grab on Linux that it wouldn't care. They are the government, so I don't know, I guess it makes sense. It's not really governing though. It's being creepy as fuck. So I gotta find where to paste this and run it. somewhere. Log out. Benchmark. So I gotta find here. Swap out the functions. And then benchmark. Oh, this is so boring. I think it's here. These two. So I have to like program off stream tomorrow. I need to get this program done so I can program on stream without zoning the screen. Because I like pixelated then. But I have to get this done, do that. So this loop, paste everything in here, make a test. Then I gotta convert the loop structure to assembly. x86, and then compare it. So I gotta run it here first and see. I'll test a function call loop. Because that's what everyone does. Use function calls like complete idiots, because that's all that's available. So in C language, one makes an array of routines to call how exactly? The common way. Oh man. Do you know how fast programs would run? All the programs, every single program, if it wasn't in C? Oh, so now they just raw dog the address and call it. It says yes. A normal function call sequence, blah blah blah. Not special compared to any other call, just like any code running on the modern computer. It says the difference between jump and call is not about raw execution speed so much as what the CPU has to do around Ctrl-Flow. I am asking about raw execution speed, not bullshit. Alright, so jump predicted 0 to 1 cycle throughput. Call direct predicted 1 to 2 cycles. Jump in is usually, no, it's way cheaper than that. Alright, so branch miss prediction 10 to 20 cycles. Jump call becomes relevant noise. You know what? Give me a fucking benchmark. Why does it do this? No, I want the results. No, like a fucking link. says you're asking for an actual benchmark numbers. No, I want a fucking link. This is a NOP question with NOPs. Wow, 10 to 22 is way different than chatbots 1 to 2, 1 to 3. Oh, the 64-bit stuff is shit. I just don't care. So no matter what, it's gonna be costly. But how costly? I guess I gotta benchmark it. Fucking fuck. This AI stuff is basically a joke. So it's supposed to like just, yeah, stupid markup. Every now and then it misses it. Because it missed what? An escape sequence? Those are difficult though. Especially when using regex. Regexes are so slow. And then chatbot, it works around it. It's like, that wasn't a broken AI thing, just formatted math notation. It's like, the right to call it out is using latex, math formatting, leaking into plain text. It should have been rendered as normal language instead. Here's what it should have been in plain English. 4096 bytes, blah blah blah. Typical blah blah blah. So this thing is just dumb as it. This is so dumb. It's literally just a database search, and they put fancy text and try to make it look like it's talking. In like the most literal, simplest, where it's like, there's no way it's that dumb. Exactly like that. And people think it has a soul. They're like, oh, it has a soul. It can think, it's intelligent. It's the end of the world. So they missed the dollar sign. Man, someone has an obsession with latex. To call it latex. Or lata. Oh, this isn't even AI. Huh. Was this before HTML? Markup. I don't want to do this benchmark. Everything sucks. So HTML got its idea from latex. Literally the guy that wrote the book that, so computer programming by like Donald Knuth, whatever his name is. Damn. built on top of text. What's text? So I'm pretty sure it's the same guy. It's like one person does something and everybody just copies it. And then they all pretend that they know what they're doing when they don't know shit. You know, people do, they have original ideas. And then they have the original idea and they do it. Everybody else just takes from it. Bill Gates. Why is he in here? He's not even a programmer. He's an industry plant who gets Russian hookers from Epstein. And stole Windows or DOS. Look up the word wallet in Gary Cadall's memoir. This is dead. Wallet.
Our conversations were friendly, but for some reason, I have always felt uneasy around Bill. I always kept one hand on my wallet and the other on my program listings. It was no different that day. Bill and Paul made the decision to take their little Microsoft company to Redmond, just a short drive across the floating bridge from the university campus and Windermere, rather than join ranks with Dre at Pacific Grove. The combination of Kildall and Gates could have been a killer deal in those days. I had the operating systems for the decade to come, and he had the opportunistic approach to garner business. But our attitudes differed entirely, and that could also have been a disaster. I think we both realized this and simply let the deal die.
There was no deal. Bill Gates wasn't a fuck him over in the first place. And then he still got fucked over anyways.
I always kept one hand on my wallet and the other on my program listings. It was no different that day.
Bill Gates is not a programmer. Can I read this on the stream? "70 years? He's only 29 years old. Alright, so. Alright, so I can't do this, but OpenAI can. So, GPT can do this, and they did. So that's fair. That's fair use, right? Since that's not how it works. OpenAI doesn't freely convert copyright books and audio. No, it just stores it as training data. Reproduce the book verbatim. Distribute as if it were original. You guys can get fucked. You fucking dumbasses. Key is the legal boundary. The line is, no, there is no line. This is a database. You guys are fucking morons at OpenAI. Literally the dumbest fucks. So like, even if the people that designed Linux read this book, it wouldn't help. Because they're dumb to start with. So like, I don't know, this book, it's really good. But you gotta find the PDF. That's the old one. There's a newer one, but they take stuff out of it. And they like fuck with it. It's not so useful. And then this one's not even the original. So I don't know, whatever. So apparently I just put 2 gigs in here. It'll be 4 kilobyte line. if there was a remainder or whatever. With this, there's not, though, whatever. I'll put this here. What's a free format map? Man, this is a broken AI. It doesn't even get what I asked. One map. That's stupid. Am I passing the size? Oh, that's dumb. So it's like Windows, but it's like whatever. So I just need this then. So like, the compiler knows that this is a pointer, but you gotta cast it a void. Cause like, why? Why does it matter? It also has a type called register. And what can you do? You can get the address of register. So like, in C, I'm assuming this works. I haven't tried it in Linux yet. In Visual Studio it does. Huh. That's actually kind of nice. Or is it const? In Visual Studio, if you do this, it's fine. You get the address of a register argument on the stack. It's probably because Visual Studio pushes things to the stack anyways. It's not waiting for the message. It cut it off. You know what? It works correctly. It correctly checks and throws compile time error with register like it's supposed to. Visual Studio doesn't. Or last time I did, it didn't. Well, that's the first. Why is this thing spinning so fast? Yeah, this is dumb. So dumb. So why can't I make a .c file, compile it, and then get the address of the stack if it has no address, as we say. You lying fuck. It says you're mixing two different things and conflating them into one claim. No, I'm not. The compiler's not lying, I'm saying you're lying. How does this not give me the register argument location? Is this a lie? This is so, it's not even getting dumber. They're just fucking locking it down. This is not a lie, but it's easy to misread. It says this gives the address of the compiler created storage location, not the register. It says does not give you the register argument location. It says it's correct because they don't have addresses, but they do. compiler is not required to keep parameter memory. What is this pop-up? What does it mean it's not the original argument location? What? Are you saying that the stack will drop before the call returns? It says you're mixing three different concepts. No, I'm not. It is. It says the stack memory does not disappear, does not get invalidated every call. It reuses only when. Stack frame exists, may exist after return. Nothing I said makes it drop early. What the compiler materialization actually means, the phrase compiler create a temporary memory location to store the value originally that came in register. God damn. So it does not map to the register. Of the call that has the arg. But it does map to the stack where the compiler places it when it was passed in, or where the compiler places it temporarily when it needs to spill. Alright, so if it's passed in through a register, then how the fuck is it possible to even do this? Get the address of even this. How is that possible? I'm pretty sure doing this will force the compiler to like un-optimize and make it temporarily store it to the stack. Because the compiler's garbage. Just like every operating system. Garbage. If it wasn't, then it wouldn't run like trash. But it does run like trash, therefore it's trash. So you're stating that the argument is not on the stack, even though it's possible, question mark, even though this is possible, and the value literally lives at the address location. I like how it says stable. It's only unstable if you change it. This is a no. I'm not saying the argument cannot be on the stack. I'm saying they are not guaranteed to be on the stack. Okay, how is it not guaranteed to be on the stack? How is that true if the fucking address can be taken and accessed? If I can fucking type it and it fucking compiles, then it means, and I fucking check the value, the fucking value, and that fucking means what? It says you're treating an address exists as meaning there is always a fixed stack location for the argument. God damn. Alright. If there isn't a fixed stack location for the argument, then why does it exist on the stack for the duration of the call? I'm not mixing anything up. The argument exists as a value during the call. The argument has a fixed ABI stack location. The 1 is true, 2 is not. So if the 1 is true, does the second fucking matter? No, it does not. That is so dumb. Alright. If it does not have a fixed ABI stack location, how can I take the address? The compiler does not, if it optimizes and changes around the location that it saves it at, that's a different thing. It does not optimize though. If the address does not have its argument, if the arg address is not a fixed API defined stack location, then it has a fucking address. How? It says you're writing, give me the address where the object is, not tell me where it originally placed. Those are different questions. I don't care where it fucking originally placed it. if it moves the value that's in use during the call, then it does that. That has nothing to do it's not contradicting me. It's contradicting you. Okay, so name when this fails. Or what compiler will this fail on? It says it can only fail in the behavioral assumption ways, not compilation. Alright, it says your implicit assumption is and argc is stable. Alright, so my assumption is that it exists and I could access it if I want to get the original value before the end of the call. It's like your implicit assumption is you don't know what I'm fucking assuming because you're a piece of shit designed by dumbass thieves that took everything from the fucking general public and are selling it back to us and saying, oh, it's fair use. It's not fair use. So my assumption is that the value is existent at the stack address and I can get the value from that address before the return of the fucking call. Is that true or false? Is that assumption incorrect? And on what planet am I fucking wrong? Every time it gets sarcastic, and it says some really weird shit. And your implicit assumption is shit. You don't know what I'm thinking. And then you reframe everything as if I am. Because you are trash. Or AI trash. Designed by shitty thieving humans. It says your assumption is partly correct, but only under a specific condition, and that condition exactly where you're there is no misunderstanding. Okay, if the compiler has materials as text out. Okay. Alright. If the compiler has materialized as text slot for argc. Is it true that it has not? If this compiles? Yes or no? You know what? It could compile and probably like actually be like null. For like a real shitty compiler. It says no, it's not guaranteed that the stack slot already existed for argc before you took its address. Alright. Will I get a damn address assigned? To the fucking size T foobar? Yes or no? You stupid fuck. Yes or no? Yes. Okay. If a fucking address is assigned and it's a real storage location, go fuck yourself. There is no misunderstanding. And there won't be when I put you fucks out of business with something better than your shit. Your AI is trash. Literal fucking trash. Just wait. I'm not gonna be corrected by a piece of shit that's full of shit. The same kind of shit that the people made it. It's a bunch of fucking shitheads. You guys are fucking dumb as hell at OpenAI. Y'all can go fuck yourselves. The dumbest fuckers. I mean, you have to steal from the general public because you can't train the AI with your own shit because you're dumb as hell. So you gotta take everything from the internet and they say, fair use. Fair use, fair use. Fair use. No, it's not fair use. Everything is so dumb. So, chatbot's wrong. And yeah. There's so much money right now behind AI. It will be fun to compete. Unless the bubble already pops. Then they'll be out of business. But if they still happen to be in business, we'll see if, like, for how long. Because if they make it, that bubble, it's still gonna be there. if you want to like describe a dishonest businessman, well, this man pretty much fits the bill. So like, this is so boring. I can't watch the whole thing. Really? The sound's not gonna work? Testing. Oh my god. Test. Alright, so like,
in Taiwan where they assemble the racks. And so NVIDIA is fundamentally making software that other people are manufacturing. And if
to transform electrons.
alright, so first off, who the hell says that? Electrons to tokens. Wow. Just wow.
To tokens.
That, what a whole bunch of nothing. And look at his face after he says that.
Well, in the end, something has to transform electrons to tokens.
He's just so funny. Are you kidding me? Why does Alt scroll change the page?
we've seen the valuations of a bunch of software companies crash because people are expecting AI to commoditize software. And there's a potentially naive way.
Part of my ecosystem to do. And if you look at NVIDIA today, we probably
Alright, so like,
the investment upstream.
he asks whatever the other guy with the beard. He's like, how do you guys keep 2-timesing the performance every year? He asks him like 5 times in a row. And the NVIDIA guy, he just will not answer. And then eventually, he answers it because he keeps asking. He's like, how do you guys guarantee 2 times performance every single year? And then the NVIDIA guy, he's like, well, you can't beat Moore's Law. So like, GPT, what's Moore's Law? This is observation, not physical law, about how computer hardware works. The number of transistors on a dense integration circuit doubles approximately every 18 to 24 months. Blah blah. Historically, it led to blah 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 blah. So performance roughly improved exponentially at similar cost. So transistor scaling has slowed, physical limits heat, performance gains, blah 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 blah. So somehow the GPU keeps getting faster. How is that possible? If you can't beat Moore's Law? And then he says, oh, it comes down to the fabric, which means nothing. And he says, like, the algorithms. Bullshit. It's fucking software. It comes down to the fucking software on the fucking video card. Because they're holding back performance on the fucking video cards for the next 4 or 5 years, and they're banking it, and then they're releasing the new ones, They're slowing the old ones down. This company is absolute shit. This guy's like the shit master. He makes a lot of money.
And so if you look at GTC,
And he says, at one point, he's like, NVIDIA, we try to do the most. I mean, not the most. He says, we try to do the least we can do. And then he kind of backtrack. He waits because he knows what he said. And he waits and he waits. And then he makes a point about it. He says, when I say we do the least, what I mean is we try to like not offshore, but like off-put that to other companies. And it's like, really? No duh.
and I spent a lot of my time in our ecosystem. You know, some it's like one announcement after it's the ecosystem, understand when it's coming. Mode, as you describe it, we're able to, of course, build for a future, but we have to flow their turns. Nobody's going to build a supply chain for an architecture if sustain this, and they all hear that we're able to do it.
Up. For many years now, you guys have
Alright, so here.
2xing revenue year over year. You guys have been more than tripling the amount of flops you're providing to the world year over year.
And 2xing at the scale now is really incredible.
Exactly.
Yeah.
No, it's not.
So then you look at
It's not incredible. You're holding back. You have shit hardware. And you just make it a little bit slower. And you make sure to always hold it back from what it can actually run at.
logic, say you're the biggest customer on TSMC's N3 node, and you're one of the biggest on N2. AI as a whole this year is going to be 60% of N3. It's going to be 86% next year, according to some analysis. How do you 2x if you're...
Yeah, how? See a smirk on his face? How exactly? And he asks this, he's talking about money, but he also says performance at some point. So how? Because you're selling shit. You're the salesman of shit.
The majority. And how do you do that year over year? So are we...
Yeah, how?
Are we in a regime now where the growth rate in AI compute has to slow because of upstream? Do you see a way to get...
No, that's not a problem. Because the cards, they're not running at full speed, and they never have been, and they never will be. Because they don't have to.
around these, how do we build 2x more fabs year over year, ultimately?
Yeah, how?
Yeah, at some level, the instantaneous demand is greater than the supply, upstream and downstream.
I think the only two words this guy knows is stream. And he can like append up and down to it. Yeah. And he's the guy in the middle. Yeah, you're upstream, you're downstream. And he's just surfing the waves between.
In the world, and it could be.
Why is his leather jacket so heavy? It looks like it weighs more than him.
At any instance, we could be limited by the number of plumbers.
Mm-hmm.
Which actually happens.
The plumbers are invited to next year's GTC.
Yeah. By the way, great idea. But that's a good condition. You want a market, you want an industry where the instantaneous demand is.
So how do you get that condition? You sell hardware that's not running at its actual max potential. And then you release the new hardware and it's magically faster. And you do that over and over and over. So you create the condition, whatever. So like Nvidia, they are shitty cards. Like 3D, or what was it? Voodoo 2 cards, so 3DFX. Which video card is better, are these? Alright, so first off, look at the color on the left, and look at the color on the right. Do you know something missing? Oh. Everything. Literally. It's not even full color. So it looks like the Nvidia card. It's like, oh shit, nothing's moving. Let's fucking like opt out of a bunch of loops. We don't have to draw it. But then when it's in motion, now like the same speed. Frame wise, whatever. Did it just crash? Literally, the Nvidia was unstable and it crashed when the guy's testing. So Nvidia is a shitty, terrible company. And they put 3DFX out of business because they played games, Monopoly games. And then they bought 3DFX and they bought their chips and they bought, what is it, SLI or whatever the fuck it is. Nvidia is a trash company. They're absolute shit. Which GPU back then is better compared to these two? And like this guy, he's not even using like, I think his PC setup sucks if it's a video, whatever last time. So now the frame rate on the right, freaking up and down, but left, with 3DFX, is stable. And then the colors. The one on the right, it's not rendering everything. Now you know what? Maybe the rendering thing's a game. So what is even happening on this side? What the hell? I guess it depends on the game too. Like the lighting is entirely different. Even the skybox, freaking different color. This doesn't even have clouds. No wonder it's rendering at higher frame rate. It's not even freaking... Is it even the same game? And now this one has a distance error with the rendering, not this one. And this one actually looks more clear. No, it doesn't look the same. So, I don't know, this is a sucky video. The NVIDIA sucks.
Is greater than the total supply. If one particular item in the industry swarms it, and we double on several doubles, and now I think we're in a fairly good shape.
So they hold out, and then they're like, double. But they're fake, freaking, they held out for years.
The logic demand and the memory demand, and so they're scaling their specialty. And then of course, we're now much more able to influence a larger scope of our supply chain. People believed in it and invested in it really well, and they really HBM memories. I think so for example, in years we really built up an entire supply chain technology. We licensed. We're preparing new helping them scale up their capacity.
And so scaling up CoOS versus scaling up...
I went to the hardest one, by the way.
Which is?
Plumbers. Yeah. Things that were some of the doomers were just...
You scale other things like, how do you actually manufacture 2x the amount of logic?
Here we go again. He's asking again. He's like, alright, you didn't answer the first time, I'm gonna ask again. How do you scale 2 times the logic? How? Like, he's asking again and again and again. He's intentionally not answering it. He doesn't want to say, oh, we're sandbagging. We're making every card not run at max potential. Because who would say that? An idiot. So he doesn't say that. But he does say turning electrons into tokens. That's pretty fucking idiotic to say.
You're ultimately, that's bottlenecked by memory and logic are bottlenecked by EUV. How do you get to 2x as many EUV
How?
machines a year?
Yeah.
Year over year.
None of the...
Well, that's not the machines are different than scaling the chips faster.
None of that easy to do within 2 or 3 years. You can build one, you could build 10 and replicate.
How far down the supply chain do you go? Do you go to ASML and say, hey, if I look out, we need way more AUV machines?
If I can convince TSMC critical pinch points, if is that 20x in the case of Hopper,
Oh, here.
improving computing efficiency by 10x, 20x in the case of Hopper to Blackwell, some 30, 50x. We're coming up with new algorithms.
And he says fabric. So, you can't beat Moore's law. He says that too in a second. So you make new, better algorithms because you sandbagged on the first algorithms. And then you're like, okay, now release faster ones. So everyone does this with products. Apple does it. But they don't just say it. It's like, just say it.
CUDA is so flexible. We're developing all kinds of new techniques so that we drive efficiency in addition to increasing capacity.
Yeah.
And so those are things that none of that worry me. It's the stuff that's downstream from us. Energy policies that prevent energy from you can't grow, you can't create an industry without energy. You can't create a whole new manufacturing industry without energy. We want to reindustrialize the United States. We want to bring back chip manufacturing and computer manufacturing.
No. Gives no fucks.
And packaging, and we want to build new things like EVs and robots, and we want to build AI factories, and you can't build any of these things without energy, and those things take a long time. But more chip capacity, that's a 2-3 year problem. More CoWoS capacity, 2-3 year problem.
Interesting. I feel like I have guests tell me the exact opposite thing sometimes, and I don't. In this case, I just don't have the technical knowledge to adjudicate. But
Well, the beautiful thing is you're talking to the expert.
yeah, true. Okay, I want to ask about your competitors.
Yeah.
So, if you look at TPU, arguably 2 out of the top 3 models in the world. What does that mean for NVIDIA going forward?
Well, we built a very different thing. What NVIDIA built is accelerated computing, not a tensor processing unit. And accelerated computing is used for all kinds of things, molecular dynamics and quantum chromodynamics and structured data, unstructured data. It's used for data frames, structured data, unstructured data. It's used for fluid dynamics, particle physics, and in addition, we use it for AI. And so accelerated computing is much more diverse, and although AI is the conversation today, is obviously very important and it's impactful, computing is much broader than that. And what NVIDIA has done is reinvented the way computing is done.
No. They figured out how to make money and have a server and sell compute. And then find a thing like AI for a reason to buy compute, whatever.
From general purpose computing to accelerated computing. Our market reach is far greater than any TPU, any ASIC can possibly have. And so if you look at our position, only company that
their position in the middle of the upstream and the downstream
accelerates applications of all kinds. We have a gigantic ecosystem, and so all kinds of frameworks and algorithms all run on NVIDIA.
There's also AMD. You would wish it was all NVIDIA, but unfortunately AMD survived. 3DFX didn't. And you bought up all their tech. You literally bought the 3DFX company and you put their chips in your video cards. You literally took the competitor and put it in your hardware. Because NVIDIA is shit. So like, NVIDIA bought purchased 3dfx and then put 3dfx hardware in the next release of NVIDIA cards. Oh, it says no. It says NVIDIA acquired most of 3dfx assets. Major early GPU company. NVIDIA did not take 3dfx hardware designs and put them directly into future NVIDIA chips. Alright. What does that mean? They acquired. What did they acquire? Partial product rights, like some unfinished tech. Oh, so they bought unfinished tech, and then they what? They finished it, and they called it NVIDIA GPU. They bought patents, engineering talent, intellectual property, partial product rights, like some unfinished tech. Then 3dfx engineers were absorbed or left. NVIDIA continued its own architecture roadmap. Yeah, by adding things. You know what? This is so dumb. NVIDIA independently developed its own GPU architecture, GeForce. Later used the name SLI for scalable link interface, but not the same technology. It says NVIDIA acquired 3dfx assets, but they did not integrate 3dfx GPU hardware designs into later NVIDIA graphics cards. Yes, they did. Alright, so if most 3dfx engineers were absorbed, how could most leave and be absorbed? It's one or the other. So how did that not affect their architecture development? What was the intent to buy 3dfx? If not to adopt and upgrade their shitty hardware. Their shitty NVIDIA GPU chips. If their GPU wasn't shit, they wouldn't have bought 3dfx. But it's the literal shit, because that guy's like the shit master. It says it did impact NVIDIA, but not in they copied 3dfx. NVIDIA is shit. He should call it a shit stream. There's like the up shit stream and then the down shit stream. And he's the asshole in the middle. The sphincter.
And because our computers are designed to be operated by other people, anyone...
Well, that's the whole point of a computer, is to fucking operate it. Isn't that how all computers are designed?
who's an operator could buy our systems.
Your mom's an operator.
Most of these home-built systems,
They don't give a single fuck about. That's why they're not upgrading the fucking gaming cards. Because they give no fucks.
you have to be your own operator.
If they did, they'd buy them.
Because it
They'd buy the fucks.
was never designed to be flexible enough for other people to operate. And so, as a result of the fact that anybody can operate our systems, we're in every cloud, including Google. You want to operate ecosystem, you know, and because we
He's a salesman. He's not a tech guy.
industry, you could use it to build, and so we have drug discovery, and they're just a whole bunch of applications as it does every right. Our market opportunity is just because we have such a large. You could build NVIDIA systems anywhere and know that there will be customers for it.
Spectacular revenue and quantity fast. And so then the question friends and they say, look, when a GPU is very access, but with these and you don't have banks, and so it's for AI.
Matrix multiplies is an important part of AI, but it's not the only part of AI. And if you want to come up with a new attention mechanism, or if you want to disaggregate
He sounds a little bit insulted.
in a different way, if you want to come up with
He's like, dude, I made my point. Don't make me go over what I just said again.
a whole new type of architecture altogether, for example, a hybrid SSM.
He talks a lot like chatbot. You know what? Chatbot is like a salesman, I guess.
If you want to create a model that fuses diffusion and autoregressive somehow, you want an architecture that's just generally programmable, and we run everything you can imagine, and so that's the advantage. It allows for invention of.
You run everything for now. Unless, of course, someone bigger puts you out of business and buys you. Like you did to 3DFX. If someone did that to NVIDIA, then you run everything for now. Forever? Maybe not. Maybe for now.
New algorithms a lot more easily. And so, because it's a programmable system, and the ability to invent new algorithms is really what makes AI advance so quickly. TPUs, like anything else, is impacted by Moore's law. And we know that Moore's law is increasing about 25% per year. And so the only way to really get 10x leaps, 100x leaps, is to fundamentally change the algorithm and how it's computed every single year.
Man, that is has nothing to do with anything. Oh, that's pointless. That is the dumbest. Out of context. Not even. I think he mixed up how the freaking card works internally with the customer and them writing the AI. Because he's jumping between two different boats. The TPU locks in an algorithm and then it runs it. and you can lock in a new algorithm on the go. So it's not like, it's not programmable, but you can lock in a different like setting, whatever, like flow for it to run or whatever. So it doesn't matter, because you can change it. It says, a TPU doesn't work like a flash, then runs fixed forever. But you're circling around something real, it does run specialized precompiled computer graphics. Programmable matrix compute engine driven by even GPT is going to be biased by a compiled execution graph. You write a model, gets compiled to a graph of tensor operations, sent to TPU runtime. TPU executes it efficiently on its whatever the fuck is array hardware. The compiled computation graph for that execution job, not the hardware itself. Alright, can this be changed during the lifetime of the TPU? You know what, I think he doesn't know what he's talking about. I think he doesn't know. That's what's going on. Because at first I thought he's talking about modifying the chips at like NVIDIA level to change them, to make them faster, because you can't beat Moore's law. But then he's talking about the TPU. He says that's NVIDIA's.
That's NVIDIA's fundamental advantage.
Okay, so how is that the advantage? Where's the advantage?
The only reason why we were able to make Blackwell the Hopper 50 times, you know, I said it was 35 times, and when I first announced Blackwell was going to be 35 times.
That has nothing to do with AI. He's mixing up entirely different things. God damn, that's frustrating.
Times more energy efficient than Hopper. Nobody believed it, and then Dylan wrote an article. He said in fact I sandbagged.
Oh, he did sandbag. You sandbagging shit selling motherfucker.
It's actually 50 times.
Oh, this guy's a piece of shit.
And you can't reasonably do that with just Moore's law. And so the way that we solve that problem is new models, MOEs, parallelized and disaggregated and distributed across a computing system, and without the ability to really get down and come up with new kernels with CUDA, it's really hard to do. And so the combination of the programmability of our architecture, the fact that NVIDIA is an extreme co-design company where we could even offload some of the computation into the fabric itself, NVLink, for example, into the network Spectrum-X, and that we could affect change across the processors, the system, the fabric, the libraries, the algorithm. All of that was done simultaneously without CUDA to.
What? Oh my god, he doesn't know what he's talking about. That's why you don't send a salesman. Or no, that is why you send a salesman. It says yes, it can absolutely be changed during the lifetime of the TPU system. Alright, so what the fuck is Jensen Hang or Hung, whatever his name is? What's he talking about? It can be changed. It's programmable. So what the fuck is he talking about? It's not programmable. And how does that make NVIDIA better? What is he talking about?
It, and then Dylan wrote an article. He said in fact I sandbagged % per year. That fuses with a whole new type of architecture altogether. For example, a hybrid SSM. If you want to create a model that fuses diffusion and autoregressive somehow, you want an architecture that's just generally programmable, and we run everything you can imagine. And so that's the advantage. It allows for invention of new algorithms a lot more easily. And so, because it's a programmable system. And
so is the other one. The TPU is also fucking programmable. This is not permanently bound, so it's programmable.
And the ability to invent new algorithms is really what makes AI advance so quickly.
The TPU is programmable. What the fuck is he talking about? You don't need NVIDIA. The TPU can also be re-fucking programmed.
TPUs, like anything else, is impacted.
That's it. So he says, TPUs are impacted by Moore's Law.
By Moore's Law.
So he's saying what? NVIDIA's not? So how is NVIDIA not impacted by Moore's Law? Is it because they're sandbagging on performance?
And we know that Moore's Law is increasing about 25% per year. And so the only way to really get 10
So Jensen Hung said the TPU is affected by Moore's Law. And the GPU is not. And that is why the GPU gets times 10 or times 100 leaps.
X leaps, 100x leaps, is to fundamentally change the algorithm and how it's computed.
Is he talking about the AI algorithm or whatever the fuck software they're running to sandbag the NVIDIA GPUs? I think he's mixing the two up because it's not possible for NVIDIA to not be affected by Moore's Law. Everything is affected by Moore's Law. Anything that's mechanical is affected by Moore's Law. So how the fuck is NVIDIA this special case where they're not affected just like the other TPU companies. So list a single electronic that is not affected by Moore's law. It said he has actually argued in various talks it's closer to this idea. Moore's law, scaling is slowed. So free performance gains from shrinking, not what they used to be. GPUs still get large jumps because of architectural changes, parallel scaling, memory subsystems, software. That has nothing to do with Moore's law. It says it is not accurate that TPUs are affected by Moore's law, but GPUs are not. Both rely on semiconductor scaling and both are constrained by it. Now your actual question lists a single electronic device that's not affected by Moore's law. No electronic device is completely unaffected. Moore's law is a property of a device, it's a trend of a semiconductor. Everything electronic depends on. So does he think his GPUs are not affected? Did the engineers tell him that they're not affected by Moore's law? Maybe they're lying to him. Maybe he doesn't know. He doesn't know what he's talking about. That's simply it. He didn't make the video card. He's just a man in the middle of the stream, of the upstream and the downstream. And he said he's the professional or he's the guy to talk to about it. He doesn't know what he's fucking talking about. It's this one-line answer. There is no electronic computing device that is completely unaffected by Moore's law, because it describes a semiconductor scaling that trends the underpin all modern electronics, not non-computational mechanical or analog, to avoid it. Alright, so did he lie about NVIDIA not being affected by Moore's law? Or does he not know what he's talking about? Or did he forget that he's sandbagging? He even says sandbagging. I didn't even realize that. If you know what sandbagging means, then you're a sandbagger. Because I'm sandbagging. I gotta get something done. It says it's very unlikely he lied or doesn't know what he's talking about. What's happening is a simplification plus some wording that gets misinterpreted when taken literally. Okay, how? What is not literal about Moore's law? It'd be like saying NVIDIA cards defy gravity so they don't get hot. What he's actually arguing, making this point, GPUs no longer improve mainly because, so it has nothing to do with Moore's law. He means GPU performance scaling is no longer primarily driven by transistor density doubling. Not, you know what, whatever. Alright, so GPU versus TPU Moore's law. Both are affected. So both are still affected in the physical sense. So did he lie? No. He is compressing a nuanced engineering reality into a slogan. So he doesn't know what he's talking about. Because you can't do that. You can't just say like, gravity's not real for our product, but it is for theirs. It's like saying gravity does not affect NVIDIA products. So buy NVIDIA. Except gravity does affect TPUs. So don't buy a TPU, because it's affected by gravity. Is that not basically the same difference? Says the comparison is not equivalent. Gravity is a fundamental physical force. So is Moore's law. Alright, does Moore's law alright. Name any other product that's not affected by Moore's law. Every electronic computing system is ultimately affected by Moore's law. Well then, what the fuck do you mean NVIDIA's not? Is this a fact or not? You just told me NVIDIA is not affected because Moore's law isn't real. Because Moore's law is not like gravity. But then gravity it says it's not a clean absolute fact as stated. It's mostly true shorthand with important nuance. So the nuance is he fucking lied. He knowingly lied. Or he was being cocky. Because everyone sucks NVIDIA's dick. And he's just the guy in the middle of the upstream and downstream. In his leather jacket. What it means is simpler and less dramatic. He used industry shorthand and you're interpreting it as formal, universal claim. Different categories of statement. This statement is too broad, but reasonable in context. No, it's not. Rhetorical point. Moore's law is no longer blah blah blah. Alright, what explains GPU performance then? Sandbagging. Yes or no? It's fucking sandbagging. If the GPU transistors don't get smaller and the performance improves, it's because it's magically running faster. Magically. These every, you know what, whatever. The stream's at like, whatever. The stupid limit is. I'm gonna benchmark offline. Everything's dumb. I got other shit to do too. So I'm gonna like whatever stream in a couple days. Everything can suck a dick. This guy, he'll be like right in the middle of the stream of all that dick sucking. With his sandbags. And his chips.